going to continue talking about statistics, and the most basic sampling technique is called a simple random sample. Other sampling techniques that are used to obtain random samples are systematic, cluster, and stratified sampling. Why is it so important for samples to be obtained randomly? Well, so that every number of the population has an equal chance to be in a sample, and the sample is representative of a population. It will also help to reduce bias within the sample. What if the process of collecting data is too expensive, difficult, or time-consuming? Suppose you're an architect who is hired to design earthquake-resistant buildings. How would you test your design? Well, you could simulate, by using a simulation, a numerical representation of a real-world event. One commonly used method of simulation is to use a random number table. So what we do is, there's these tables all over the place, and you can find them anywhere. You do a random number generator somewhere online, and you get these tables, and sometimes they're broke up, sometimes they're not. I actually prefer them not broken up. It depends on, what you're looking for. It says when you flip a fair coin, heads should come up 50% of the time and tails should come up 50% of the time. How can a random number table simulate flipping a coin? Well, at the right is part of a standard random number table. It says let 0 through 4 represent tails. So if you see a 0, that represents a head. If you see a 1, a 2, a 3, or a 4, those would all indicate a result of getting heads. If you get a 5, 6, 7, 8, or 9, that would indicate or represent a result of getting tails. So it says the top line is 20 numbers. How many heads and tails do we get from the top row? Well, 7 would be heads. 3 would be 7 would be tails. Wish my camera. 7 would be tails. 3 would be heads. 7 would be tails. 3 would be heads. 5 would be tails. 4 would be heads. 5 would be tails. 9 would be tails. 6 would be tails. 3 would be heads. 7 would be tails. 8 would be tails. 1 would be heads. 3 would be heads. 4 would be heads. 6 would be tails. 3 would be heads. 8 would be tails. 7 would be tails. Heads would be 3 would be heads. So if you count that up, it says we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 heads. And 1, 2, 3, 4, 5, 6, 7, 8, 9 tails. It says, is there another way we could have used numbers to define heads and tails? You can do whatever you want. You could say, let even numbers be heads and odds be tails. That would be one thing. You could say, let 0 be heads and 1 be tails and ignore all the other numbers. The possibilities are endless. That's the neat thing about a random number generator table, is you can set it to anything you want. All right, so it says, see, what if you flip a coin and get 5 heads in a row? Based on simulations, do you think the coin is fair? So if I look at this, 5 heads in a row would be the numbers 0 through 4 altogether in a set of 5. So if I break these up into 5s, which is what they did, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, each one of these blocks basically represents an outcome then. And I'm looking for any of those outcomes that come out to have all numbers between 0 and 4. So if I go through and I look, there's one here, there's one here, there's one here, and there's one here. Excuse me. So if I calculate that probability, It only happened 4 times, and if you count, there's 1, 2, 3, 4 across, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 4 by 15 means there's 60 sets of 5 there. So my probability is about, if you type that in, it's 0.067, which is going to be about 6.7%. So it said, what if we swapped values and made 0 through 4 represent heads? Well, then if you looked for, I just did that backwards, didn't I? I did all of this backwards. No, yes, I did. 0, oh, for crying out loud. 0 through 4 was supposed to represent tails, and 5 through 9 was supposed to represent heads. That's where my numbers got screwed up here. I apologize. See what I get for doing it ahead of time? So these are all backwards. 7s, it would be a head, tail, head, tail, head. Small numbers are tails, heads, 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 tail, heads, heads, tail, 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 heads, tail, heads, heads, tail. There we go. Alright, and so I actually found the wrong ones. Those ones would have been, not even pencil. Those would be all heads, and those would be all heads, and those would be all heads, and those would be all heads. I got that wrong. And that one would be all heads. So there's still only 4 out of 60. And then if you do the other one, I apologize, guys. If you do the other one, that's where you get this one, and this one, and this one, and this one. And that would be your 4 out of 60 down here. So if we swap, there's still only 4 out of 60, which is about 6.7%. Alright, and since that's a fairly small percent of times that it happened, it's probably not a fair coin. Alright, so what about some other ways to use a random number generator? Well, it says we have 75 people and want to take a simple random sample of 6 of them. How could we do this with a random number table? Well, again, there's tons of possibilities. We could number them alphabetically, 1 to 75. Notice you don't want to use 1 and 75 because whatever your interval is, how many ever digits is in your highest number has to be the number of digits in your lower number. So you have to pick the same number of digits every time. Alright, so to describe how I'm going to use the table, I'm going to choose 2 digits at a time until you get 6 pairs between 0, 1, and 75. These people will be in the sample, ignoring repeats and numbers greater than 75. So if I look at 2 numbers at a time, and this is where I don't like the breaks because sometimes they don't break up very nice and you got to read across a gap. But you see how I split them into 2 numbers at a time. So if I just start, the numbers then would be 73, 73, 54, 59, 63, 78, 13, 46, 38, 73, 02, 96, 55, 83, 03, 90, 70, 82, and you could keep going forever and ever and ever. I need to just go long enough. I'm only trying to pick 6 out of these 75 people. So, but my numbers only go from 0, 1 to 75. I can't use the same number more than once because you can't pick the same person twice. All right, remember these are representing people. All right, and you have to ignore all the numbers that are greater than 75. So there would be my first guy. I can't repeat, I already used him. That's between 0 and 75. That's between 0 and 75. There's my third guy. There's my fourth guy. There's my fifth. No, I can't use 78. That's bigger than, I don't have 78 people in my sample. So there would be my fifth guy. and 46 would be my sixth guy. Okay. All right. So why did we need to skip some numbers on the second simulation, but not with the coin flip situation? Well, because you can't pick the same person twice being the sample, and you can't use numbers higher than 75. When we were doing the coin flip, whatever you flipped first didn't affect what you flipped the second time. All right, so it says, notice that it is very important to define their labels properly. How would you define labels for each of the following to use with a random number generator, random number table? Okay, I could say 40% of adults are registered as Democrats, 50% as Republicans, and 10% as independent. Well, if you break this up, again, when you do this, when you're talking percentages, you could either go out of 10 or you could go out of 100. For example, if I went out of 10, 40% would mean 4 out of 10. 50% would be 5 out of 10. 10% would be 1 out of 10. All right, so I could say that 0, 1, 2, and 3, because that would be the first four numbers, are Democrat. A 4, 5, 6, 7, or 8, because you need 5, are Republican. And a 9 would represent independent. All right, 45% adults are registered as Democrats, 35% as Republicans, and 20% as independent. Now I don't really want to go out of 10 because this would be 4.5 and you don't have decimals. So I need to go out of 100. So I would say, and again, I don't really agree with what they did. I mean, I guess you can do whatever you want. It's your table, but I would have went 0, 0 to 45 is Democrat, 46 to 80 is Republican, and then 81 to 100 would be your independent. That's the way I would have done it. All right. C says you have 569 students and want to take a simple random sample of 5 of them. Well, since you have 3 digits in your total, you're going to have to read it 3 digits at a time. Right? So you would have to, again, all your numbers have to have the same number of digits, so you'd be going with assign each person a number from 001 to 569. D says you have 7,000 workers at a company and want to take a simple random sample of 120 of them. Well, you could assign each number, again, do the same thing, but now you have 4 digits, so you'd have to go 0001 to 7,000 alphabetically. Okay, so those are possibilities. All right, Professor Snidely is designing a multiple choice test with 10 questions. Each question will have 5 choices for answers, A, B, C, D, and E. Professor Snidely wants to use a random number table to determine which letter choice should correspond to the correct answer for a question. It says define the labels for your answer choices. And you guys you could pick whatever you want. Again, it's your number generator. You can do whatever you want. I said let choice A be a 1, choice B be 2, choice 3 be C, choice 4 be 4, D, choice E be 5. And I'm going to ignore all the other digits. So using the random number table below, and again, so you can make it as big as you want. Obviously, the more you use, the more accurate you get, but we just use these. So if I break it up into 5s, 1, 2, 3, 4, 5, because there will be the first question. Each question has 5 answer choices. So a 1 would be A, so my first question is going to be A. I have to ignore 0. 2 is a B. 4 is a D. 2 is a B. 5 is an E. Skip 0. Skip 6. Skip 9. 2 would be a B. 1 would be an A. Skip 8, 9, 7, 7. 2 would be a B. Skip 8. 3 would be a C. Skip 7. Skip 0. And skip 8. 2 would be a B. Skip 6, 6, 9. Skip 8. 3 would be a 6. 2 would be a 6. 3 would be a C. 2 would be a B. 3 would be a C. And 6 I'd ignore. Now, I don't need all of those. He only has 10 questions. So 1 should be A. 2 should be B. 3 should be D. 4 should be B. 5 should be E. 6 should be B. 7 should be A. 8 should be B. 9 should be C. And 10 should be B. I didn't need to figure out the rest of those. Okay? Alright. So it says Denise made a deal with her brother, Aaron, that when they roll a number cube, she will do the dishes if he rolls an even number, and he will do the dishes if he rolls an odd number. In 1 week, 7 days, an odd number has come up 6 times. Aaron thinks his sister is cheating and wants to conduct a simulation using a random number table to see how typical this occurs if the number cube is fair. It says determine labels for your outcomes. Well, I'm going to say that 0 through 4 are even and 5 through 9 are odd. Okay? And then I'm going to, using the random number table below, determine how many times 6 odd numbers appear in a group of 7. Conduct 30 simulations. So what I do is, if I break these up into 1, 2, 3, 4, 5, 6, 7s, 1, 2, 3, 4, 5, 6, 7, and you have to look. If we want all odd numbers, we're looking for a set of 1, 2, 3, 4, 5 numbers. Well, you want a set of 7 numbers that have a 5, 6, 7, 8, or 9 in them. All right, and let's see, what did I do? Oh, wait. Oh, I need 6 out of the 7 numbers to be odd. Okay, so that comes up. That comes up here. It comes up here. And it comes up here. And that's it. All the rest of them. And again, you're going, wait, miss. What about that 2? What about that 2? Dang it. Hold on. What about that 2? That's not an odd number. No, but it said how many times does 6 odds? 1, 2, 3, 4, 5, 6. Again, this one we have to take the 2 out, but there's 6 odds. This one we'd have to take the 0 out, but there are 6 odds. That's 3, and if you count how many sets there are, 1, 2, 3 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 3 out of 30, which is 0.1, which is approximately 10%. So, there's only a 10% chance that that could occur. So do you think she's cheating? Yeah. All right. So it says a large manufacturer of batteries knows that historically 10% of its batteries come off the production line defective, and the remaining 90% of batteries come off the production line in working condition. The president of the company wants Bob to bring him 10 working batteries. Bob doesn't have time to test them. How many should he grab off the production line to make sure that 10 of them work? So we know that 10% are defective, sorry, and 90% are working. All right, so what I'm basically trying to do is figure out how many do I have to grab to make sure that 10 of them are working. All right, it says conduct a simulation to estimate how many batteries the company needs to pull off the production line in order to be sure of ending up with 10 working batteries. Describe how you will use a random number table to conduct this simulation. it is okay to is it okay to use repeated values? Okay, so what I decided to do, again, you could do anything you wanted to do, but I decided to let 0 mean that it was defective, because if 10%, that means 1 out of the 10 numbers has to be defective, and the other 9 numbers have to represent working. And what I'm going to do is I'm going to choose one number at a time until you get 10 numbers between 1 through 9, and repeats would be okay. So we've got 3 trials, and he just did a random, he got a random number table from, I don't know, somewhere, the internet probably. All right, and so if we look, if it is a 1 through 9, it works. So that's a work, that's a defect. Work, 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 defect, work, work, work. And I need 10 working. 1, 2, 3, 4, 5, 6, 7, 8. Work, 9, 10, work. Yeah? Which means I get, what is my outcome? Well, I had to pull 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 batteries to make sure that 10 of them were working. In trial 2, work, 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 no, work, no, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I only needed that one. So I had to pull 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I only had to pull 11 that time. I know I only had to pull 1, 2, 3, 4, 5, 6, 7. Oh, I only had to pull 10. I didn't need that other one. I only had to pull 10 to get 10 working batteries. For trial 3, defect, when, working, working, doesn't work. There's 4, 5, 6, 7, 8, 9, doesn't work, 10. So on this one I had to pull 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I had to pull 13 in order to get 10 working. So to be safe, I should pull 13. All right. Alright, so oops. It says Yvonne buys a hollow coin from a magic shop. She wonders whether the coin is evenly weighed. As a test, Yvonne plans to spin the coin several times and record whether it lands heads up or tails up. It says, if the coin is evenly weighted, what would you expect the result of Yvonne's experiment to be? Well, if it's fair, I would expect for it to land on heads half the time and tails the other half the time. Yvonne spins the coin 3 times and it lands heads up each time. Can Yvonne conclude whether the coin is evenly weighted? If so, explain. If not, what should she do next? 3 times is not enough trials. Really. You should conduct multiple trials and take the percentages. Okay? Alright, you try this one, hit pause, come back when you're ready. And hopefully you got 24. It says, Stephen predicted that 30% of the students in his school will name math as their favorite class. To test his prediction, he surveyed a random sample of 80 students and recorded the number who named math as their favorite class. How many students naming math as their favorite class would provide the strongest evidence that Stephen's prediction was correct? Well, what is 30% of 80? Well, that's 0.30 times 80, which would be 24. Yeah? Alright. Margin of error. It says, even when collected randomly, different samples will produce different statistics. For this reason, we can calculate that our results are correct within a certain margin of error. This can be calculated using the formula. Margin of error equals 1 divided by the square root of the sample size, or E equals 1 over the square root of n. So, in my next question, it says, in a survey of 1,200 teenagers, 48% said they are involved in an extracurricular activity. What is the margin of error for this survey? Well, here's my formula. So that's going to be 1 over the square root of my sample size, which was 1200. That gives me 0.0228675,135. And it says the margin of error, we want a percentage, 1, 2, that would be 2.3% margin of error. So B says if you conducted another survey and the result this time is 53%, does this fall within the margin of error of your first survey? Well, if I did another survey, okay, if I base it on this, that means that my answers can be anywhere from 48 plus or minus 2.3%. So that would be, if I do 48% plus or minus 2.3%, that would leave my, I don't know what we want to call it, your, within the margin of error, I don't know, like you can keep the answers that are between. If I do 48 plus, this side would be 48 minus 2.3, this side would be 48 plus 2.3. That leaves me my values between 45.7 and 50.3. All I got to do is figure out, does my answer fall in there? And they got 53%. Is 53 between 45.7 and 50.3? No. So, no, this does not fall within the margin of error. Alright. So, a recent survey of 1,000 shoppers showed that 70% were planning to charge their purchases. What is the margin of error for this survey as a percent rounded to the nearest tenth? Well, I am going to do my margin of error equals 1 over the square root of my sample size, which in this case is 1,000. And that gives me 0.0316, which is a margin of error of approximately 3.2%. The second survey shows that 68% were planning on charging their purchases. Does this fall into the acceptable range found in the first survey? In the first survey, it was 70%. So now that says 70% plus or minus 3.2%. So if I take my 68, I want to see, does it fall between my 70 minus 3.2, which would be 66.8, and my 70 plus 3.2 would be 73.2. This does fall between there, so yes. Okay. You try, no one. When 800 voters were polled, 53% said they were voting yes on an initiative measure. Find the margin of error in the interval that is likely to contain the true population percent. So my margin of error is going to be 1 over the square root of 800, which is approximately 0.0354, which is approximately 3.5%. So if 53, my margin of error is going to be 53 plus or minus 3.5 degrees, which says that the interval that it's okay on has to be between 53 minus 3.5 would be 49.5, and 53 plus 3.5 would be 56.5. Yeah. Alright. We try one, hit pause, come back when you're ready. And hopefully you got 400. It says, according to a recent survey, 32% of American teenagers in a random sample said they prefer science class to math class. If the margin of error is plus or minus 5%, about how many students were surveyed? Well, this one's kind of a trick. They're giving me the margin of error. They're telling me that that is plus or minus 5% equals 1 over percent. I should write as a decimal. 1 over the square root of n. So I'm going to multiply by the square root of n. I have plus or minus 0.05 times the square root of n equals 1. Yeah. So then I'm going to divide by 0.05, and I get the square root of n equals 20, and then square that, and I get n equals 400. Alright, so we are done. Happy homeworking, and I will see you